Why humanoid robots are suddenly leaving the demo stage. For years, humanoid robots mostly lived in the same place as concept cars and trade show miracles. They danced, they waved, they did backflips. They looked just convincing enough to make people imagine a robot future that always seemed 5 years away. But dancing was never the real test. The real test is whether a robot can show up in a warehouse or a factory, move through a space built for humans, handle objects without breaking them, work safely around people, and do it again tomorrow and the day after that, and thousands of times after that. That is the shift happening now. Humanoid robots are starting to move out of the demo stage and into places where performance matters more than spectacle. And that matters because the modern world is already built around the human body. Our stairs, tools, shelves, doors, and carts were designed for 2 hands and a body that can reach, lift, turn, and walk through narrow spaces. If robots can operate inside that world without forcing us to redesign everything around them, the economics of automation change fast. The question is no longer just whether humanoid robots can move. The question is whether they are finally becoming useful. The first reason this is changing is simple. The problem was never only mechanical. Building a machine with legs and hands is hard, but that is not the whole puzzle. A useful robot also has to perceive messy surroundings, respond to variation, recover from mistakes, and deal with a world that does not stay neatly arranged for it. Factory parts shift, boxes deform, lighting changes, people walk through the frame. A system that works only in a perfect lab is not a worker. It is a prop. What changed is that robotics is being pulled forward by the same wave that pushed AI into language, vision, and pattern recognition. The latest push in humanoids is not just better motors or balance. It is better perception, better training and simulation, better control software, and better ways to turn huge amounts of visual and physical data into action. That is why so much of the current conversation is about what companies now call physical AI. The body still matters, the batteries matter, but the real race is to build the control layer that turns a machine from a pre-programmed device into something more adaptable. That leads to the second change. The industry stopped talking only about what humanoid robots can do on stage and started asking where they can do something economically useful first. The answer, at least for now, is not your kitchen. The first serious deployments are showing up in warehouses, logistics, and manufacturing, because those environments have a mix of structure and mess. They are predictable enough to operate in, but still built for human movement. That makes them the natural testing ground. This year, Agility Robotics announced a commercial agreement with Toyota Motor Manufacturing Canada after a pilot with plans for its robot Digit to support manufacturing, supply chain, and logistics work. Reuters also reported that Skild AI and Nvidia were deploying a general-purpose robotic control system onto robots working Foxconn assembly lines in Houston. Nvidia also announced new humanoid hardware partnerships with major chip companies, a sign that the supply chain around these machines is beginning to harden into something more serious. That does not mean humanoid robots have arrived in the way science fiction promised. It means the conversation has moved from isolated stunts to early commercial trials and industrial bets. But there is a third reason this moment matters. For years, industrial automation mostly avoided the humanoid form. If a factory wants to repeat one precise motion forever, a fixed robot arm is usually better. It is faster, cheaper, simpler, and easier to secure behind a barrier. Wheels are often more efficient than legs. Specialized machines usually beat general ones. So why build something so complicated at all? Because the human world is full of edge cases. There are countless jobs that do not justify building a dedicated machine, but still involve repetitive physical work in spaces designed around human reach and movement. Carrying totes, loading parts, moving bins, navigating narrow aisles, working at stations that were never built for a robot arm bolted to the floor. In those cases, a general-purpose machine starts to look more attractive, even if it is not perfect. That is the real bet behind humanoid robots. Not that they will outperform every industrial machine, but that they may handle enough human-shaped work to become useful across many environments. And that is exactly where the hard part begins. Because leaving the demo stage is not the same as winning. The problems are still brutal. Reliability is one of them. A viral clip can hide 100 failed attempts. A factory cannot. A machine that works beautifully for 3 minutes and then needs help is not a workforce revolution. It is downtime. Dexterity is another problem. Human hands are still extraordinary. We grasp, rotate, adjust pressure, and recover from slip without thinking. For robots, those tiny corrections are often the difference between smooth work and constant failure. Power is another limit. The more capable the machine, the more energy, cooling, and computing it tends to need. That creates a trade-off between mobility, endurance, and cost. And then there is safety. A humanoid robot is not just software, it is software attached to a heavy moving body. In a home, that is difficult. On a factory floor, it is non-negotiable. Even the industry's own language reflects that tension. The International Federation of Robotics says humanoids now have to prove reliability and efficiency against standard industrial automation. Not imagination, not investor excitement. Reliability. Cycle times, energy use, maintenance, safety. The boring metrics are the real gatekeepers. That is why the smartest way to understand this moment is not to ask whether humanoid robots are amazing. They are. It is to ask whether enough of them can become dependable enough, cheap enough, and adaptable enough to cross an invisible line from impressive technology to ordinary infrastructure. And that is still unresolved. What we do not know yet is how wide the real market is, how fast costs will fall, how much human supervision these systems will still need, and whether the humanoid form will beat simpler alternatives outside a limited set of jobs. But even with that uncertainty, something important has already changed. The center of gravity moved. Humanoid robots are no longer being judged only by whether they can look convincing in a controlled performance. They are being judged by whether they can enter the existing human world and do useful work inside it. That is the only test that matters. If they pass it, even partially, the result will not feel like a sci-fi invasion. It will feel quieter than that. A robot at the end of an aisle. A robot moving parts between stations. A robot doing work people stop noticing because it becomes normal. And that may be the clearest sign that the demo era is ending. Not when the robots look most futuristic, but when they start to look boring. Because boring is what real infrastructure becomes when it starts working. And the next question is even bigger. If humanoid robots do become useful at scale, what matters more in the long run? The machine's body or the AI system learning how to control any body at all?